Right. Precalculus students, going to do for you here from section 3.1, numbers 57 to 64. They come in two sets. They want us to make a table for 57 that looks like this, where we have the number of times we're going to compound interest and then the amount we're going to get. We have 1, 2, 4, 12, 1, 2, 4, 12, 365, and then continuously. All right, we're going to try to make this as easy as possible for ourselves. So if you look in your notes, the formula for interest compounded some number of times per year is A equals P, that's the principal amount, like how much the investment was, how much you started with. That's the rate, the R. N is the number of times you're going to compound here. And then raised to the N T power. Right? So in this particular one, we are going to, let's see, for 57, our R is 2%, so that's 0.02. The T is 10 years. And then we're going to do it for different N's. And did they say the principal? Oh, in the A, the principal is $2,500, the starting amount. That was given like in a little blurb above, and that's true for all of these problems. Okay, so here's the way I'm going to do this. I'm going to show you some calculator moves. Sorry, for those of you who do not have a graphing calculator, what I'm going to show here does not work for you. It does work for our TI 83, 84 folks. So I'm basically going to just make something that looks just like this. Now, since the principal is the same for all of these, I wouldn't need to make a variable name for that because it's just going to be $2,500 for all of these problems, 57 through 60. And then on the inside of this, I want to have parentheses 1 plus, then I'm going to do R over N. The R is going to be 0.02, but that's only true for 57. So I'm going to go ahead and put the letter R in there. How do I get the letter R? I go to the alpha, and there's, pointing off screen here. There's the R right there. So I'm going to go R over N. Going to get alpha N is right here. Like that. And I want to raise that to the NT power. Raise that to the alpha N T, the NT power. Right. Now, the calculator doesn't know what any of those things are yet, so I'm going to go ahead and hit enter, and it gave me an error there because I hadn't told it anything, but that's fine. I'm just going to quit and get out of there. And now I'm going to tell it what these different letters are equal to. I'm going to, let's see, for this problem, right now 0.02 is my R, 0.02 is my R value. I want to store that. That's my STO store button. that makes a little arrow come up on your screen. I'm going to store that as the letter R. That's a one-way arrow. It has to be the number first and then the letter. I'm going to enter that. And then I'm going to make t equal to 10. So I'm going to type in 10, and I'm going to store that as t. And then I want to do this for different n values for n equals 1, 2. So I'm going to start with n equals 1. And store that as n. Oops. Calculator's not going to like that. Store it as alpha n. There we go. Okay. Now that I've got all that set up, I'm going to go back, entry, entry. I'm doing second entry to get back to this expression. And now I have it all set up with the numbers that I want. I'm going to hit enter. So the first thing in my table is $3,047.49. If you remember in the last video, I set this to 3 decimals. Because I'm doing money now, I'm going to go ahead and set that to 2. All right. Now the next thing, I want everything to stay the same except I want n to turn into 2. So I'm just going to type 2, and I'm going to store that as n. And then I'm going to do my second entry. That's just scrolling back through the different things that your calculator had in the active line. Second entry, going back through those. I think I'll try it in a sec. I think you probably also just scroll up. So now I got 3,050. Didn't make my table big enough. Sorry, 48 cents. And now I want to do n equals 4. So I'm going to do 4 second, store, and then bring up my n, and then bring that down again. So I got it a different way. I just scrolled up with the arrow. So either of those will work. 3,051.99, 30,51.99. So you see, as we compound more times, get a little bit more money. I want to store 12 as my n now. And then want to do this again. So this is just saving me typing that whole thing in multiple times. I'm going to store 365 as my n. And with practice, you get faster doing this. And then I'm going to scroll back up to that. Grab that. $3,053.49. And then to do it continuously, that's a different formula. That is my A is equal to, this is the PERT formula, P e to the RT. So to do that, I'm just going to do that the one shot. My principal is 2,500, and then I'm going to do my e to the, my rate is 0.02, and my time is 10 years. So that's my P equals e to the RT for this stuff. And it should be, what we're expecting is that it's going to be something just a little bigger than that. If we compound continuously, hit enter, $3,053.51. $3,053.51. All right. That's fun, huh? All right, so for 58, I'm going to try a slightly different way, and you can tell me, we can decide if we like it any better or not. That wasn't quite as, honestly, was not quite as fast as what I thought it was going to be. So 1, 2, 4, 12, 365, continuous. Trying to leave myself a little bit more room. See if I did it. All right, so for this, let's try again. Now I'm going to set up this formula for this one. I'm going to do these, try to do them quick again, but set it up in a slightly different way. You can tell me if you like this way better or not. And the other thing I'm going to do, I think before you do this video, I'm going to make these problems just the odd numbered ones, because I don't think that we need to do this much calculator crunching. So I'm actually going to skip 58 and go to 59. So that's, my principal is still 2,500. 1 plus my R is 4%, 0.04, divided by the N is going to change, and the T is 20. So N is the only thing that's going to change as I go through the table in this problem, right? So instead of doing it the way I did storing all those letters, let's try this instead. Let's try 2,500 times 1 plus 0.04 over, for the first one it's going to be 1. And you know what I'm going to do? Actually, I'm going to back here. If you have a calculator that's set up with the, if you have a TI-84 Plus, it probably knows how to do this. I'm going to go alpha F1, and that brings up the possibility of making a fraction here, option number 1, that actually looks like a fraction. And that's going to let me put in the 0.04 here and a 1 here, right? Raised to the time is going to be the same for all of them. The time is 20 years. And the N, forgot the N when I wrote that out, times, and in this case it's going to be times 1. So that's all the numbers that get me the first thing in the table, right? That get me this. So 5,477 and 81 cents. Now to do it with a 2, I'm going to go second entry, and I'm just going to go back in here and change that to a 2 and change that to a 2. I think I like this better. I think it's going to be faster. $5,520.10. And then to do it for 4, I'm going to go back to second entry, pull that up again, change those to 4s. 5541.79 for 12. And this is why I did the fraction bar thing, because I can turn that into 12 and it's not going to mess up like how many spaces there were. If you don't do the fraction thing, could possibly have an issue with that. At 5,556 and 46 cents. If you need help doing this with your particular calculator, you let me know. We can figure it out together. Together we are Rockbridge. I'm going to pull it up one more time and do it for 365. $5,563.61, and then to do the continuous one, that's a different formula, so I have to enter it again. This is $2,500 times, this is the PERT formula, times E, oops, not that, times E to the R T. Just leaving that there. Make sure you look at that, understand that those are the right numbers for this. So that's $55,063.85. So you can see as we compounded more times, we did get more interest, and that's like the limit of how much interest you can get if you compound continuously. All right. Glad I took out those even numbered ones. Yikes. 61. This is, we are doing just compound interest, but now for different numbers of different amounts of time. So I'm going to try to do this in one table here. See if you can see what I'm doing. So for times 1, these are times now, how many years? 10, 20, 30, 40, 50. I'm blowing up my table because I'm realizing I'm not going to have room to write these big money values. And then we're going to have the amount that we have. Here we're starting with $12,000, and for 61 the rate is 4%, so 0.04, and for 63 the rate is 0.035, 3.5%. Okay, so what I need is this PERT formula. That's here we're starting with 12,000, that's my P, my principal amount, times E to the, for 61 it's 0.04 times, and then my T values. So I'm starting with T equals 1. So that's going to be $12,489.73. That's how much you would get, 4%, if you leave it in there for a year. What about 10 years? Going to bring that back up here, go back in here, change that to a 10. $17,901.90. Sorry, that's so messy. You can see it right there. That's the number there. And then how about for 20 years? Second entry. Just going to change that to a 20. $26,706.49. How about 30 years? This is why you want to start investing when you're young. $39,841.40. 40 years. And it's going to be $59,436.39. And last, for 50 years, $88,668.67. There you go. So that's compounded continuously at 4% for different amounts of time. That's what we did in that table. I should be able to bring that up because for number 63, it's the same idea, just a different percent. So this is 3.5%, so it should be kind of similar to those values, but a little bit less, right? 44. And then I'm going to do it for 10 years. And then I'm going to do it for 20 years. And then I'm going to do it for 30 years. Then I'm going to do it for 40 years. And you can see in the long term, this is a lesson, something to know about investing. In the long term, that half a point, like this is 3.5%, this is 4%, that doesn't seem like much, does it? 0.5% of interest. But when you project that forward in time, you can see we're talking about a difference over 40 years, more than $10,000 there. And then last, I'm going to do it for 50 years. Almost $20,000 difference. All right, calculator.